This is the solution to the SHM basic with damping question. It starts with calculate the frequency of the oscillation from this graph. So from the graph, of course, we can get the period. We've got 1, 2, 3 periods in 5.4 seconds. So 3 times the period is 5.4 seconds. So the period then is 5.4 divided by 3. The frequency, of course, being 1 over the period, is 3 divided by 5.4. And that'll give us 0.5 recurring. So to 2 sig figs, which seems reasonable, we've got 0.56 hertz. State the magnitude of the amplitude. Well, it's the maximum displacement from the equilibrium position, the rest position, and I would read that as 0.075. Be some tolerance on that, especially given the quality of the copy, but 0.075 or thereabouts, 0.074 to 0.078 maybe as a tolerance there. State how the frequency and amplitude of a simple pendulum are affected by the damping. Well, the frequency will be constant. The amplitude decreases. Draw on figure 1 the displacement time graph for a pendulum that has the same period and amplitude, but is pi by 2 out of phase with this one. Well, that means you're going to go from a sine graph to a cos graph. And so you just need to be careful to draw that correctly, showing there we go, showing that this is a maximum when this is 0, and this is 0, and this is a maximum, and so on. So you can see how I have marked on my points and then drawn my smooth curve through them. Then in part C, the pendulum bob has a mass of 8 times 10 to the minus 3 kilograms. Calculate the maximum acceleration. Well, the acceleration, of course, maximum acceleration is omega squared a, or minus omega squared a actually. And we've worked out the frequency. So we can use omega as 2 pi f. And then we can stick our values in there. And we'll get 0.91. Notice that I'm using more sig figs here. When we worked out the frequency 0.555, I'm using that in there rather than 0.56. So I'm not rounding to sig figs until the very end of my calculation. Then the total energy of the oscillation. Well, the energy, you may recall, the maximum energy in either case is a half m omega squared a squared. If you don't remember that, then hopefully you'll remember that The maximum velocity is A omega. I should have V max in there. And so, since kinetic energy is a half mv squared, then if we square this, we get a squared omega squared, a half m omega squared a squared, which is what I said to begin with. Then, sticking in our numbers, we'll get 2.7 millijoules there. And that's the end of our question.